Welcome back to my YouTube channel. It's me again, Webster's Ratio, your tutor in mathematics and sciences. So we want to continue with organic chemistry part 5. Specifically, we'll be looking at carboxylic acids. But before we continue, don't forget to like and share the video, and most of important, please don't forget to subscribe. Hit that red button and become a subscriber. Becomes the family who will be the first person to be notified whenever I post the video. Okay. Also, don't forget to leave some comments in the comment section below. I'll be happy to respond to your queries and also, your concerns on what should be uploaded on this channel. Okay. So, carboxylic acids is a group of homologous series made up of weak organic acids. So, this is made up of weak acid. Is a group of homologous series made up of weak acids. Specifically, these are called the organic acids. So all organic acids are weak acids, and they are called the carboxylic acids. Organic acids, these are acids made from organic materials, from living organisms. Okay, that's why they're called organic acids. The properties of these organic acid or carboxylic acid in general, they are the same as the properties of the acid which we have been learning in other topics, like the hydrochloric acid, nitric acid, and many others. They have the same properties. They are not so different because they are acid. You get that, eh? So the physical properties of organic acid or carboxylic acid, they have the sour taste just like the French, like the other acids. Apart from that, they also turn the blue litmus paper red. So they are normal acids. Okay. Now, apart from that, we need to know the functional group of this carboxylic acid. You must know the functional group. Okay, so the functional group of these acids, which are carboxylic acid, is the COOH. This is the functional group. You can see the difference from alcohols. In the previous video, we said the functional group for alcohol is just OH. Now for the carboxylic acid is COOH. This is carbon, oxygen, and hydrogen there. Now, if you want to draw the structural formula of this functional group, it's C. The first oxygen forms a double bond with carbon, and you have the OH there. Okay? Plus any group which can be there. R represent any alcohol group. Okay? Not alcohol, but alcohol. Okay? The alcohol. Now, when you know the functional group of carboxylic acid, you also must know the next part is the general formula. So, looking at the general formula, it will help us to know how to write the molecular formula, the structural formula as well. So, the general formula. Okay, general formula. The general formula for this organic acid is this CnH2n plus 1. Then at the end there is a CO. There is its functional group. Okay, that is the general formula for this acid. Now, if you want to know the molecular formula for a carboxylic acid with one carbon, this group is different. You don't start with one, okay? Because this carbon which is in the functional group is also counted as one. Okay, so if you want to know the functional group of the organic acid with one carbon, you start from 0. Meaning that where there is N, you have to put 0. So, for example, where there is N, we put a 0, we have C0, H2 times 0 plus 1, then we have the CO beside. Okay? Which is C0 is 0, this goes. Then we have 2 times 0, which is 0, plus 1, which becomes 1 hydrogen. So 1 hydrogen is there, and the CO2 remains. This is the carboxylic acid with one carbon. Okay? The naming is not so different. It is similar to other organic acid. Okay? Just a minute. Okay, sorry for the disturbance. Okay, now I'm saying that this one is a bit special, so if you want to know for the carboxylic acid with one carbon, you have to put 0 where there is N, and we are going to remain with one carbon there from the Cu, which is the functional group. Okay, so the name of this, is not different from alkanes. The alkane with one carbon, okay, I'll change here, I'll write here so that you understand that. So here is an alkane, then here is a carboxylic acid. Okay. Now what we do, from the name of an alkane, we are going to drop this E, we remove the E, and put the oic, O-I-C. We put the oic at the end of the word alkane. Okay. So for example, what do we call an alkane with one carbon? An alkane with one carbon is called methane. Okay. Alkane with one carbon is called methane. So at the end of this methane, we are going to drop this E and add this, of which it becomes, methanoic. We have removed the E and put the oic at the end of the day. Butanoic acid. Okay, so the naming is similar to that of alkane. We just drop the E, then at the end we add the word, the letters OIC, the oic. So this becomes a methanoic acid. So this is methanoic acid, an acid with the one carbon. Okay. Now the structure formula for this methanoic acid, is we draw the one carbon, then we have one hydrogen this side, and we said the first carbon forms a double bond with this, then we have the hydroxyl group there. So that is the structure formula for methanoic acid. Okay, that's the structure formula. Now what about an acid with the two carbons? So instead of putting 2, remember we started from 0, so we have to put 1 for us to know an alcohol with 2 carbons. While there is N, we'll put 1. Okay. So we have, while there is N, we put 1, so C1, H2, 1 plus 1, then we have the Cu at the end of the day. The Cu. Then we have C1, which is just C, then H, 2 times 1 is 2, plus 1, that is 3, then we have the Cu at the end. Okay? So this is an acid with the 2 carbons. We have 1, 2. I said the carbon on the functional group is also counted. So here we have 2 functional groups. What is the name again? First identify the name of an alkane with the 2 carbons. What's the name of an alkane with the 2 carbons? Is what? Ethene, or ethane, sorry. Ethene is an alkene. So we say ethane. So at the end of ethane, you are going to remove the E and put oic. Okay, we put oic, so this becomes the ethanoic acid. So that is ethanoic acid. At the end there, we just remove the E and put the oic at the end, it becomes the ethanoic acid. Okay, the structure formula for ethanoic acid, first draw the 2 carbons, because we want to have 2 carbons there. We have 1 and 2. Now do not forget this, always the functional group of acid is always at the first carbon, never the second carbon. The third carbon is always at the first carbon. Okay, so now this one can be the first, that one can be the first. We want to have 2. Okay, so I said the first oxygen forms a double bond, then the other oxygen remains with the hydrogen there. Then this carbon, it has 3 hydrogen. You can see that. So that is the structure formula for ethanoic acid. Okay, just one more example. we're going to now we look at an acid with the 4 carbons. So when you say an acid with 4 carbons, where there is any, don't put 4. Do not put 4. Out of those 4 carbons, this one is already counted. Okay, so instead of putting 4, put 3. So we put 3 where there is N. We have C3 H2 times 3 plus 1, then Q. Okay. Now we continue multiplying. We say C3 H2 times 3, that is 6. 6 plus 1, that is 7. Then we have Q. Okay. Then you need to know the name of this carbon and this acid. It has 4, of course. 1, 2. See that, eh? So first, as usual, identify the alkane with the 4 carbons, which is butane. Now, at the end of butane, drop the E and add the oic. So this becomes the butanoic acid. So this is butanoic acid. Very easy if you have seen. It's not tough at all. So this is butanoic acid. So the butanoic acid, you have to draw each structure formula. You need to know the structure formula of this butanoic acid. Okay? So the structure for butanoic acid, write the first write first 4 carbons, because there are 4 carbons, 1 and 3, then the other one there to make it 4. So 1, 2, 3, 4. Always the functional group is at the first carbon, so it forms a double bond with 1 oxygen. The other one remains there. There is a bond there. Remember in the first video we learned that carbon must have 4 bonds to be stable. Okay, so this one is stable. This one becomes stable as well. Okay, this one also becomes stable. This one also becomes stable. So this is the structure formula for butanoic acid. You can continue, do more and more of this. Okay, now how can you produce this acid? How can you make this organic acid? How can you make organic acid? Organic acids are made from oxidation of alcohols. We discussed this in the last video. Organic acid can be made from oxidation of alcohols, which is the addition of oxygen, or maybe any oxidizing agent. So making of organic acid or production. Making of organic acid. Organic acids are made from oxidation of alcohols. Oxidation of alcohols. Organic acids are made from oxidation of alcohol. The addition of oxygen to an alcohol, or the reaction between alcohol and an oxidizing agent. Okay. Now, apart from the oxidation of alcohol, we also have what is called the hydrolysis of esters. Hydrolysis of esters. The hydrolysis of esters. These are the two major, reactions in which you can make this carboxylic acid. But some carboxylic acid exists naturally, like in fruits, like the acetic acid, which is the complicated or the complex organic acid, acetic acid. So those, they occur naturally. Okay. Now we have oxidation of alcohol as well as what hydrolysis of esters. This is the addition of water to an ester, which is the opposite of esterification, the reaction we did in the last video on alcohols. We said the alcohol reacts with the acid to produce an ester. Now here, an ester is reacting with the alcohol. So this is the reaction taking place, ester. Okay, ester plus water. Ester plus water, we are going to produce organic acid and the carboxylic acid. carboxylic acid and the alcohol. Carboxylic acid plus alcohol. So when talking about hydrolysis of esters, is the opposite reaction of esterification, where you add water to an ester to produce carboxylic acid and the alcohol. Okay, so hydrolysis is the addition of water to an ester to produce a carboxylic acid and an alcohol. Thus, these are the two major reactions which you can produce what here? The carboxylic acid. So you can make a carboxylic acid by just adding water to an ester. Okay. Now the name of the ester and alcohol made will depend with the name of the ester which you have used. Okay. For example, if you have reacted maybe ethyl ethanoate, if you are to react ethyl ethanoate plus water, the product, we say ethyl ethanoate, it means the first part is ethanol, the second part is ethanoic acid. Always the first part of an ester is an alcohol. So we're going to have ethanol as the product, as well as plus ethanoic acid. Okay, so that's a reaction which you can make for it to produce a carboxylic acid. Okay, now when you know how to produce a carboxylic acid, you must also be able to explain the use of these acids. What are the uses of these acids? The uses of organic acid. Organic acid are used as in food preservation. If you want to preserve food from getting damaged, so they use organic acid, that is in food preservation. Apart from that, these organic acid are also used in antivenom. I'll just give you two. Let me know the other use of organic acid in the comment section below. So I've just mentioned two here. One, the organic acid are used in food preservation to preserve food, to keep them to exist for a longer period of time. Apart from that, these organic acids are also used in antivenom. Antivenom, this is where maybe you have been bitten by an insect. Now they want to neutralize the chemicals of that insect which is in your body. They use some of this organic acid. Okay, so let me know the other use of organic acid in the comment section below. You will win if you be the first person to text 2 uses of organic acid. I'm going to send you the airtime of 5 kwacha. Okay, so be the first person to get the airtime of 5 kwacha. Just comment in the comment section below 2 uses of organic acid. Okay, so this is what I have for you in this video. I hope you have understood. It is clear. If it's not clear somewhere, please leave the question again in the comment section below. I will be happy to reply to that comment and make it clear, reaching up to your needs. Okay, thank you. Have a good day. Bye-bye.